Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. Excuse me. We are here because we want to learn algebra. Today is our lesson number 200. Day number 200. We are in the process of solving the word problems from day 101 through 200, and today is our very last day, the day 200. We have done 99 word problems already. Today is our 100th day of solving a word problem, because in the first 100 days we did these concepts. We learned how to, on the first, for those of you who do not know, who are not familiar with the schedule, in the first 20 days we learned how to evaluate algebraic expressions. Day 21 through 50, over the next 30 days we learned how to add and subtract algebraic expressions. Then over the next 25 days we learned, day number 51 through 75, we learned how to multiply algebraic expressions. And then over the next 15 days, day number 76 through 85, we learned how to divide algebraic expressions. And finally, over the next 15 days, 86 through 100, we learned how to solve linear equations. And then after that, starting from day 101, we have been doing word problems. We have been learning how to solve simple word problem dealing with simple linear equations. Today is our 100th day of doing just that. The problem for today is already on the blackboard. I'm going to read it to you and we'll solve it together. It says the digits of two-digit integer are reversed. So we have a two-digit integer. Let's just make something up. Let's say 36. It's an integer. It's a two-digit integer, and we are told that the digits of the two-digit integer. This is a two-digit integer. We are told that its digits are reversed. So if it was 36, we do not know. If it was 36, it becomes 63. As a result, we are told, the number obtained differs from the original by 18. As you can clearly see, 63 does not differ 36 by 18. The difference is much larger. 63 minus 20 would have been 43, so of course the difference is more than 20. Here, the difference has to be 18. And the question simply is, how much do the two digits differ? How much do the two digits differ? We are not being asked what that integer is. We simply ask, what's the difference between the two digits? For example, here, the two digits differ by 3. Because the 10 digit is 3, the unit digit is 6, the two digits differ by 3. You get the idea. Now, before I start solving the problem, it is very important, it is vital, it is crucial that you watch day 151 and day 182 and understand the concept that we went over, that we learned on those 2 days, day 151 and day 182, because I won't have the luxury of repeating everything. I'm just going to set it up. The question is, how do we express the notion of a two-digit number in the language of algebra? That's the question. And if you know that, the rest is downhill. And that's what you're going to learn in these 2 days, day 151 and day 182. For example, if I have a number 27, here the unit digit, let's actually, before we let's start a solution first. Let's pretend the unit digit is u for unit digit, and let's pretend that the 10 digit is, you got it, t. So if I have a number here, let's say if I have a number of, say, 46, how do I write that? Do I express that as TU? No, we do not express that as TU in the language of algebra, because TU in the language of algebra implies T times U. For example, if I write down AB, if A is some variable, if A is some number, and B is some number, AB means A times B. How do I express the notion of 46? If T happens to be 4 and U happens to be 6, how do I express the notion of 46? That's the question. And this is how we do it. You see, 46 I need some water. You see the 46 is actually made up of, the reason why it's called 46 is because it's made up of a 40 and a 6. That 4 is not a 4. That 4, by virtue of being in the 10th place, is not a 4, it's a 40. Therefore, if t happens to equal 4, then we have to write this as 10 times t, because t is 4. 10 times 4 is 40. Plus our u is 6. Voila. This is the part that expresses our original integer. If t is a 10 digit and u is a unit digit, then we will express a 2-digit number as 10 times t plus u. Had it been a 3-digit number, let me quickly show you the 3-digit number. Let's say, for example, 295. How would we express 295 if h equals 2, h for the 100 digits, t equals 9, 9 for the 10 digit, and u equals 5, 5 for the unit digit? How would we express 295? Well, 295 is exactly what it says. I don't know how low you can read here, but 295 is exactly what it says. It is made up of 200 plus a 90 plus a 5. I erased everything, I shouldn't have erased it. So h here equals 2, t equals 9, and u equals 5. Therefore, 295 is to be expressed in the language of algebra as 100 times h plus 10 times 9, 10 times t plus a u. Voila. That's how we express a 3-digit number in the language of algebra. Here we have a 2-digit number, 10t plus u. And then we're going to reverse the digits. Now when we reverse the digit, t ends up being here and u ends up being here. So when you reverse the digit, we end up with 10 times u plus a t. As you can see, if we were to reverse the digit of 46, 46 is going to become 64. 64 because our u is 6, 6 times 10 is 60, and our t is 4. So it becomes 64. 10 times 6 plus 4. 46 turns into 64 when we reverse the digits. Enough said, enough of the talk. See, I didn't want to do all of this thing. I wasn't planning to explain all of this thing, because that's what we learned on day number 151 and day number 182. Go and watch those videos. It is imperative that you watch those videos before you actually finish this thing. Besides, I do not know why you'll be watching this video in the first place. If you had heeded to my advice in the very beginning of the course, I told you to watch all the videos in their proper sequence. Don't skip around. So here we go. So we have a 10-digit number, we have a 2-digit number, which we are expressing as 10 times t plus a u. And we are told that if you were to reverse the digits, 10 times u plus a t, if we were to reverse the digits, we are told the digits of 2-digit integers are reversed. We just reversed it. You see, this is the original integer. We just reversed the digits. As a result, the new number obtained differs from the original by 18. This is the new number. This is reversed. And this number differs this number by 18. So this has to go first. So let's put it here. 10 times u plus a t, because this apparently is the bigger number, minus 10 times t plus a u. This quantity differs the original integer by 18. The question simply is, how much do the 2 digits differ? Well, that's pretty straightforward, very simple. The rest is very easy. Let's do it out then. So again, this is the original. This is the original. This is the reversed. This quantity is the reversed. Let's open the parenthesis. 10u plus t minus, when you open the parenthesis, we get 10t minus u equals 18. You'll see how simple it is. The rest is very easy, very simple. 10u minus a u is 9u. and 10t minus negative 10t plus a t gives us negative 9t, and that equals 18. Divide the entire equation by 9 and u minus t equals 12. Voila, u minus t equals 2. Voila, that's it. The question was, how much do the two digits differ? Well, they differ by 2. The unit digit apparently is the larger unit. The unit digit minus the 10 digit is 2. That's all. That's all we are done. That's it. The problem is finished. What I'm going to do now is just to fulfill your curiosity as to what those numbers could be. How many different scenarios are there? Well, it's very easy to figure out how many such scenarios are there, because of the fact now that we know that the two digits have to differ by 2. There could hardly be too many scenarios where the two digits differ by 2. So we're going to enumerate them. I don't know if you actually learned this word, enumerate. It's a good word to know. What does it mean to enumerate? We may have learned it, who knows? If I used it now, I might have used it before. Bloody hell, it is not in the list. I'm digressing here big time. I need the room. I need the room, so I'm going to erase the top part. We don't need any of this thing now. We have the problem now, so let's get rid of it. This. The scenario. Enumerate means to make a list of something. I hope I spell the word properly, and if I did not, then I'm telling you right now that I'm not a good speller. It's always a good idea to check my spelling. I suck at that. I am no good. Enumerate. And for those of you who have been watching my vocabulary video, would bear me out. And if you don't know what it means to bear someone out, you watch the vocabulary video. Enumerate. That is how you spell it. It's just to make a list of something. I'm going to actually make sure that I put this in my list here to cover this word in the future. It's a good word to learn. Let's enumerate the scenarios. How many scenarios could there be where the two digits differ by 2? Well, that's very straightforward. We're going to go in systematic way. We're not going to skip around. We're not going to go all over the places. We're going to go in systematic way. Again, I need more room, so I'm going to erase this part here. So this was our original integer. This is our reversed one. And let's go systematically. And if you're going to go systematically, the good idea is to start with 1. So if you start with 1, then if you reverse the digits, we get 31. The reason I put 31 on the top is because 31 is a bigger number, so the difference has to be 18. Is the difference 18? Well, let's see. 31 minus 13, 11 minus 3 is 8, 2 minus 1 is 1. What do you know? The difference is 18. Difference is 18, exactly like the problem said. The two-digit number, the digits of two-digit numbers, here the two-digit number happens to be 13. Listen carefully. The two-digit number in this case happens to be 13. And I'm going to read the problem to you verbatim. Again, if you do not know what verbatim means, again, watch the videos and learn those words. Verbatim is to be spelled with an I, not a T. When did we learn this word verbatim? I know we learned it. Verbose, verbosity, valiant, valor, volition. What the? It's not in the list. How can it be? To articulate something verbatim means to say something word for word, to say it in the exact way, the way it was said originally. It is not on my list, so we're going to learn them in the future also. We're going to learn this word verbatim, and we're going to learn enumerate in our future vocabulary videos. And again, if you still do not know what I'm talking about, in addition to the algebra video that you're watching right now, I have put together some videos which will help us improve our vocabulary, particularly if you're planning in the near future to sit for the SAT or the GRE or the GMAT or the TOEFL. It is vital that one has a decent vocabulary, and for that reason I have put together some vocabulary videos. And apparently verbatim is not one of the words that we have covered. I've done so far, I think, 63 days or 73 days of vocabulary videos. To find the vocabulary video, you use the same tag that is here, same format. Just type in Keshwani Prep dash vocab dash day 63, and you will find all the words that I covered in day 63. I cannot believe I'm just keep checking here because I was 100% sure that we learned this word, the word verbatim. But anyway, we'll learn the word verbatim, which means word for word, and we'll learn the word enumerate in our future vocabulary video. Let me read the question to you verbatim. In other words, let me read the question to you word for word, the way it was written originally on the blackboard. Okay, one more time. The way it was written originally on the blackboard. It says, digits of, read the problem with me, digits of two-digit integers are reversed. So the two-digit integer in this first scenario, the two-digit integer is 13. The digits of two-digit integers are reversed. So 13 becomes 31. As a result, I'm going to continue reading here. As a result, the new number obtained differs from the original one by 18. That's exactly it. Let's look at the second scenario. The second scenario would be, well, maybe the unit digit is, maybe we have a 2 and a 4. They differ by 2. But you see, by mistake I put 2 and a 4 at the bottom here. I cannot put 24 on the top. I have to reverse the order because the bigger number has to go on the bottom, on the top. So if you have the original number of 24, the units differ by 2, 24 becomes 42. And you will see that the difference is 18. And so on and so forth. The next one would be 35 and 53. And the difference again is 18. The difference is always going to be 18. Then the next one would be 4 and 6. 64 and 42. And then we'll have 7 and 5. And then we'll have 8 and 1. They do not differ by, what the, not 8 and 1, 8 and 6. And finally, 9 and 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Looks like there are 7 possible scenarios. And because there are 7 possibilities, there are 7 possible scenarios here, which is why the question could not possibly have asked us what the two-digit integer is. Because if you were to come to me and say that if you were to come to me and read the question to me, digits of two-digit integers are reversed. As a result, the new number obtained differs from the original by 18. What is that integer? To that, my answer would be, how the hell do I know? There are 7 possible answers, which is why that wasn't the question. We were not asked what is that integer, because there are 7 possibilities. We were simply asked what is the difference of the 2 digits. By how much do the 2 digits differ? Well, 2 digits differ by 2. 2 digits differ by 2 if the difference has to be 18 after you reverse the digits. Right here, as you can see clearly. So there are 7 possibilities. That's it. We are done. We have finally arrived at our destination. Day number 200, the very last moment of day 200. Took us a long time. I started this project almost 2 months ago and we finally arrived at it. I most likely will continue with this thing in the future. I do not know when, because there is a lot more that one can learn in algebra. This is, as I explained to you in my last video, day number 199, as I explained to you if you watched it, we have barely scratched the surface of elementary algebra, let alone higher level algebra. This is the elementary algebra, and this is almost like covering the first 2 chapters of the semester. We have barely scratched the surface. There is a lot more to learn. The next topic in the sequence would be to learn how to solve simultaneous equation, where you solve 2 equations together at the same time. And then after we learn simultaneous equations, then we have to do some word problems that deal with simultaneous equations. And those word problems are far more complicated than the word problems that we have been dealing with in the last 100 days. And after that, we have to learn how to solve quadratic equations, how to do factorizations, and many more things. There are many more topics that we can learn. But anyway, we'll see how life, where life takes us, and I might put some more videos in the future. But we'll see. Thank you. Make sure that you do watch all the videos in proper sequence and do all the problems, every single one of them, if you want to learn the algebra the way I hope that you would learn. If you want to have the solid foundation, then the thing to do is to watch all the videos in their proper sequence and do all the work, every single problem with me. All right? Thanks. Good luck.